Is there some reason why it looks filtered?
All right, so today we're going to talk about acid naming. We're going to talk about acids and base naming. And we're not going to go in really in depth right now about what an acid and what a base is. Not super in depth right now. We'll get to that at the end of the second semester, touching on acids and bases a little bit. But just to kind of introduce them, an acid, does anyone know right off the top of their head what an acid is?
Anything with the pH below 7.
Okay. Okay. Yep. Yep.
A base would be opposite.
pH above 7. Okay. What about its molecular format, or what about its atomic makeup? Do we know anything about that? Okay, acids are what we consider proton donors. Okay, proton donors. They give away a proton, and in this example, in this case, we think of protons as being hydrogen molecules, hydrogen ions. Those are protons. Okay, because an H plus ion is a hydrogen atom, and how many protons does hydrogen have? One proton. If it's a plus ion, how many electrons does it have? 0. Right? If it's a positive charge, that means we're missing an electron. So that means an H plus ion is just simply one proton. Does hydrogen have any neutrons? No, because its atomic mass is 1 and its atomic number is 1. So when we talk about protons and their transition back and forth between atoms, we're talking about the transfer of a hydrogen ion. Okay? So what an acid does is it gives up a hydrogen atom. Okay, a hydrogen ion, really, a charged hydrogen atom. Okay, so that means when we're naming acids and when we're looking at acids, they have to have a hydrogen atom. Acids have to have a hydrogen molecule. It could be more than one, it could be just one, but typically when we see acids, we see the hydrogen attached at the beginning of the name. Okay, so just to kind of give you an example of an acid, these are all types of acids. Okay, H3PO4. All of these are examples of acids. And can you see where the hydrogen is placed on this compound? Always at the beginning. Okay, they're always based at the beginning. So that's a really good clue for you that is considered an acid. Okay, hydrogen's not a metal. Just because it's sitting on the left side of the periodic table, it's not a metal. And these are made up of positively charged hydrogen atoms and negatively charged anions. Okay, could be polyatomic ions, could be just regular anions, monatomic ions. But we're looking for acids that have that hydrogen at the beginning. Okay, so that's your clue for if it's an acid or not. Okay, it's got a proton here that it is willing to donate to someone else. It wants to get rid of it. If an acid is a proton donator or donor, what do we think a base might do? Yeah, good. A base is a proton acceptor. Okay, a proton acceptor. It takes in those protons. Okay, it wants to collect a proton and become an acid, right? There's a constant transition back and forth between acids and bases. And we're not going to get too much into that now, but I want you to be able to tell the difference, okay? Bases most often end with OH, okay? So anytime we see a compound with that hydroxide polyatomic ion in it, it's more often than not a base, okay? So compounds like sodium hydroxide, potassium hydroxide, all those things are considered bases. Okay, so when we see that OH at the end, that's a big clue for us that it's a base. And naming bases doesn't go any differently. Naming bases is just the same as naming ionic compounds. So you can go ahead and put that in your notes. We name bases the same as ionic compounds. Oh, I can't write today. All right, we name bases the same as an ionic compound. So if we would see this molecule right here, NaOH, what might we name that molecule? Sodium hydroxide, right? Sodium is our metal, hydroxide is our anion, okay, or our polyatomic ion that's negatively charged, right? Sodium is +1, hydroxide we know is -1. So that's an example of a sodium hydroxide base. That's our most common base. Okay. We had a brief introduction about acids and bases, but we want to get to how to name those acids. Okay, so we're going to start with naming binary acids. Binary acids contain how many atoms? How many different elements? I'm sorry, not atoms necessarily. 2 elements. So they're made up of 2 different elements. What does one of those elements have to be in order to be an acid? Hydrogen. So it's always H plus something. Okay, in order to be an acid, it has to contain hydrogen. So naming a binary acid means it's hydrogen plus something else. More often than not, this second element is a halogen. Okay, so it's most often a halogen. What group are the halogens?
Second.
They're group 7 or 17, right? 7 or 17, depending on how we number it. If we use our system, it's 7, right? So those are things like fluorine, chlorine, bromine, iodine, acetine. Okay, so a binary acid looks like this: HCl, HF, HI, okay, HBr. Those are all examples of binary acids. Okay, and those are most simple because hydrogen is a +1 charge and halogens are a -1 charge. Okay, they fit together the easiest, right? They're +1 and a -1. They balance each other the best. Okay, I'll go ahead and make this distinction. All acids should have a neutral charge. So when we're naming acids, we go back to our ionic rules that they have to have that neutral overall charge. Must be neutrally charged. Okay, so these are all examples of our binary acids. Now let's talk about how we name them. Okay, how we name them. Let me give myself a little bit more room here. Let's start with HCl. Okay, a binary acid always begins with the prefix hydro. Okay, always begins with hydro. Then we have the root of our second element here. And it always ends in IC, acid. Okay, so this means this overall acid would be called hydrochloric acid. Okay, this is for a binary acid. We name it hydrochloric. That's because our anion comes from chloride. Right? And whenever we see IDE, we know that it's the element only, right? IDE comes from a simple anion, that's 1, a monatomic ion. Oops. So when we name binary acids, if it comes from an IDE anion, that means our naming system is hydro-blank-ic acid. All right? Questions? So let's name a couple more here. All right, so in this first compound, we put together hydrogen and what other anion? What anion did we put together with this? Bromine or bromide? Bromide, right? When we're talking about bromide and its charged state, it has to end in IDE. Okay, so we put together hydrogen plus bromide to come out with an acid called what? Hydrobromic acid. Okay, here's our root, bro, right here. We started with hydro, which is our prefix. We ended with ic, and we end with acid. Okay, we need to see what anion that hydrogen is being paired with because that determines what naming system we use. Okay, because bromide is by itself, right? We know it's singular because it ends in IDE. We can pair it with hydrobromic acid. So, Grace, what'd you have for your second one? HF. Hydrofluoric acid. Do we agree? Hydrofluoric acid. Perfect. Okay. What anion is hydrogen being paired with here? Fluoride. Not fluorine, fluoride. Tell me the difference between fluorine and fluoride. Yeah, Brayden. Fluoride is an ion. And since it's in group 7, what's its charge? 1 or -1. Good. Okay, here in our last example, does it change anything that we have 2 hydrogen atoms here?
Yes.
A little bit? How do you think so? What anion is being paired here? Sulfide.
Sulfide.
And what's sulfur's charge? Or sulfide's charge?
-2.
-2. That means we've got to pair 2 protons with that sulfide ion in order to get a neutrally charged acid, which is what we want, right? We want it to be neutral. So we've got to have 2 of those hydrogens or 2 protons to pair with that sulfide. So does it change the way we name the molecule at all? No, it's still binary. It still only contains 2 elements. So we still call this hydrosulfuric acid. Oops. So in this case, how many protons does this acid have to donate?
2.
How many could it give away? It could give away both of its protons, right? These 2 only have 1 proton to donate. Hydrosulfuric acid has 2 protons that it would have the ability to donate. How come this is where we get a little bit more complex and we start dealing with our polyatomic ions? So since we have those memorized anyway, that shouldn't be a problem, right? Yeah, that's what I thought. Okay. Okay, so an oxy acid contains usually 3 elements, could be more than 3 elements. Okay, usually 3, but could be more than that. Oxy acids contain hydrogen, oxygen, and 1 other element. Okay, they contain hydrogen, oxygen, and usually 1 other element. Okay, oxy acids is where we use our polyatomic ions a lot. Okay, so they're usually made up of hydrogen plus a polyatomic ion. Usually. Hydrogen plus a polyatomic ion. And we know polyatomic ions, most of ours are charged positively or negatively? Negatively. So they're going to work, right? Could we have an acid that's hydrogen plus ammonium? No. Or ammonia? No. Because those are positively charged. We don't mix those. So we can use hydrogen plus most of our polyatomic ions here because they're negatively charged and they pair with hydrogen. Okay? So we still need to balance our polyatomic ion with the number of hydrogens or the number of protons we need to get a neutral acid. Okay? So let's go ahead and look at pairing hydrogen and this molecule right here. What's that polyatomic ion called? Phosphate. Phosphate. Okay? So if we know that hydrogen is a +1 and phosphate's a -3, how many hydrogens do we need to pair with phosphate to get a neutral atom? 3, right? We need to have H3PO4. Okay, because phosphate has a -3 charge, hydrogen has a +1 charge. To get that to be a neutral atom, we've got to have 3 hydrogens. Okay?
And so the oxygen and the phosphate just is the oxygen that it has to have, you know, another.
I'm going to hand you out a little naming cheat sheet that we're going to work with because we name things differently depending on if it comes from an 8 polyatomic ion or an 8 polyatomic ion. Okay, we know there's a difference between sulfate and sulfite, and there's different ways that you name these acids based on those polyatomic ions. Okay, so take one. If there's extras in the back, I'll come get them in just a second.
Do you not like close those down?
Look at that acid naming sheet, and we know that this polyatomic ion or this anion that hydrogen is paired with is an 8, right? This is phosphate. So if we know that the anion we're being paired with is an ATE, how do we go about naming this molecule? It ends in IC, right? We're going to follow this anion ending. We know it ends in ATE because it's phosphate over to ic acid, which means the name of this molecule is phosphoric acid. Okay, so this is phosphoric acid because it comes from an 8 polyatomic ion. Okay? Questions on naming that one?
So like sulfuric acid, just
So let's try a few more here. Let's try combining hydrogen and this polyatomic ion. Okay, so hydrogen is +1. And what's this molecule called right here? Carbonate. Okay, so how many hydrogens do we need to balance out carbonate? We need 2 hydrogens to balance out our carbonate polyatomic ion. So we're going to have H2CO3. And this would be called carbonic acid. Very good. Carbonic acid. Okay? Now it's pretty simple when we see it put all together. When we start with our ions and we put them together. Now let's see if you can do it just starting from our acid state. Okay? If we start like this, H2SO4, see if we can name that now. Okay? This is without taking our ions and putting them together. Okay? The first thing that you do when you start to name these acids is you need to look and see what polyatomic ion sits on the right-hand side. Okay? This SO4 molecule, what do we know that is called? What's the polyatomic ion called? Sulfate, right? Because if we work backwards, we know that this 2 is going to come up to the top, and we know that this 1 is going to come up here, which means we have H plus and an SO4 minus 2. We know that this is sulfate, and since our polyatomic ion ends in ATE, we're going to call this acid sulfuric acid. Good. Sulfuric acid. Okay, so picking out that polyatomic ion from the acid is the most difficult part here. Okay, can you pick out the polyatomic ion and then you decide what does it end with? And then that'll give you the clue for how to name it. Miguel asked a good question. If it ends in IT, if we deal with sulfite, which is SO3 minus 2, and we want to combine these two compounds into one acid, that means we need H2SO3. Now we have to look and say, what molecule is this? What polyatomic ion is SO3 minus 2? This is sulfite. And that means we need to look on our acid naming sheet, and we see that ite anions end in OUS acids. Okay, so that means this is called sulfurous acid. Sulfurous acid. So for hydrogen and sulfide or sulfate or sulfur, we have lots of different combinations we can have, all with different names. Okay? So let's take a look at all the different combinations we can have with hydrogen and sulfur together. Okay, and I want you to try and name all of these. Actually, I'm going to start with, we'll just go ahead and do sulfur. So you could have H2S, H2SO3, H2SO4. Okay, all of these are acids dealing with hydrogen and sulfur. Okay, and we've named all of these so far. So this is a binary acid, which means it is hydrosulfuric acid. Okay, then we take a look at these. We see it's an oxygen in there, so we know it's an oxy acid. So we've got to pay attention to our polyatomic ion endings now. Okay, so SO3 polyatomic ion is sulfite. SO3 is sulfite, which means we are left with sulfurous. And for our last one, SO4 comes from sulfate, which means we end with sulfuric acid. Let's take a look at this. All right, so first thing we do is we determine, is it a binary or is it an oxy acid? Oxy, okay. And what polyatomic ion sits right here? Acetate, okay. This is acetate, which means when we name our acid, it's going to end in what? IC. So that means this is called acetic acid. Sometimes you'll see acetic acid drawn like this, or written like this, CH3COOH. Okay? And nothing changes here. We still have two carbons, 3 hydrogens, 2 oxygen, and our extra hydrogen. The reason that it's written like this is because of its actual 3-dimensional structure. So acetic acid molecule looks like this. Okay, so they write it like that, so it says CH3COOH. Okay, that's the only reason you'll see it written like that some different times. So if you see it like this, it's still acetic acid, it just has a different format. Okay, but anyway, that's just fair warning. No other ones really get written like that. For some reason, acetic acid's special. All right, I'm going to give you the name. Nitrous acid, and you're going to give me the formula. H2NO2. Do we agree?
Yeah.
It's okay. So NO2 minus, which means all that's going to change is going to be HNO2, right? We only need one hydrogen to balance out the nitrite molecule. So we should have HNO2 for nitrous acid. Now, do we agree?
Yep.
Good. Okay. Nitrite is NO2 minus 1. Okay, Abby, what do you think for the second one? Chloric acid.
I have HClO.
HClO. Do we agree? Not quite. Okay, that's okay. So, chloric means it has to come from what polyatomic ion? It needs to come from chlorate. What's chlorate's formula? ClO3. So we're missing that 3 on your oxygen. Okay? You had it balanced correctly, but we were missing those other 2 oxygens. So chlorate is ClO3 minus 1, which means chloric acid should look like this, HClO3. Yeah? Okay? So IC ending means our polyatomic ion needs to come from 8. OUS ending means it needs to come from ite. And what about our last one here? Jake, what'd you have? HI. The Nitrous acid. Okay. HI. Hydroiodic means it's coming from what type of an anion? IDE. And that means we know it's a singular type acid. I'm sorry, a singular anion. Okay, so go ahead and try all 3 of these. Correct. Okay, so nitric acid comes from hydrogen plus a nitrate. Nitrate is NO3 minus 1. So that means we need one hydrogen atom to balance that nitrate. Let's look at, Robbie, why don't you tell me what you have for H3PO3? What's our name?
Phosphorus acid.
Phosphorus acid, perfect. Okay, because this hydrogen is being paired with phosphite, right? Phosphite is PO3 minus 3. PO3 right here is a phosphite molecule, and since it's phosphite, that means that our acid has to end in OUS. So we have phosphorus acid. Okay, and last one here, Carolyn, what'd you have for oxalic acid? H2C2O4. What polyatomic ion does oxalic come from? Oxalate. So we paired hydrogen plus oxalate, which is C2O4 minus 2. Okay, and since it ends in 8, we know that our acid ends in ic. Right, either the name or the compound, you decide is it ionic or covalent, then you give me either the formula or the name, right? You're going to give me the opposite of whatever I give you. Raise your hand if you agree. Perfect, right? Permanganate is MnO4 minus 1. So sodium has a +1 charge, which means they balance each other out with no extras. Okay, permanganate is MnO4 minus 1. Abby, what'd you have for the second one? hydrobromic acid. Perfect. Perfect. Because Br comes from bromide, right? Hydrogen is paired with bromide. If our anion ends in IDE, then we go hydrorotic acid. Okay, perfect. Cece, what'd you have for the third one? Si2O3. Disilicon trioxide. Perfect. Disilicon trioxide. Remember, the first one gets to keep its regular ending. We don't say disilicide. We say disilicon trioxide. Okay, our last anion gets the IDE. Okay, and Payne, why don't you give me the last one? Okay, so this type of a molecule, this top one, was it ionic, covalent, or an acid? Ionic, because it's a metal and a nonmetal. The second type, was it ionic, covalent, or an acid? Acid, good. What about third? Covalent. And what about the fourth? Covalent. Perfect.